is done in collaboration with Mrs. Alice Fontaine of the University of French Guiana and Mrs. Samira Yacoubi of the University of Perpignan. This work carried out in the simulation laboratory named SpaceDev allows to develop a method to simulate the dynamic of desertification in time and space. This picture presents an area subject to desertification process. In these pictures, we notice that the soil is degraded, the vegetation are dry. Land is in the global process of degradation. Its state can evolve in time, and the degradation sources such as climate and human activities spread to neighboring areas. These two facts explain the need to make a spatio-temporal modeling. According to United Nations Convention to Combat Desertification, in short UNCCD, desertification is land degradation in arid, semi-arid, and dry sub-humid areas due to various factors, including climatic variation and human activities. It has consequences that can be serious for the environment or human well-being in its life. It affects 1.5 million people worldwide and affect a quarter of the land in more than 100 countries, through a reduction in soil potential, cultivable land in worldwide, decrease in surface and groundwater, cause damage to crops, livestock, electricity productivity, insufficient food production, poverty, upheaval, social, rural exodus. Our work consists to make a spatio-temporal model of desertification phenomenon based on the coupling of two models: MEDALUS assessment to quantify desertification factors, and cellular automata model to make the MEDALUS model dynamic in time and space. The aim is to predict the land state at each time step. MEDALUS assessment developed by the MEDALUS project on commission of the European Union use 4 desertification factors such as soil, vegetation, climate, and management. The combination of the 4 desertification factors give a desertification sensitivity index DSE brought its geometric mean. MEDALUS is DSE. If the DSE is in the interval I5, the state of land is qualified to very degraded. And if the DSE is in I4, land is very degraded, and we define the range for high, moderate, and low at the same way. MEDALUS allow to assess land degradation at specific time, years, according to the special property of desertification. Cellular automata is used to make it dynamic. In order to construct our spatio-temporal model, we define all the components of cellular automata. Cellular automata consists to divide a space to the regular grid. Mathematically, cellular automata is defined by a tuple LSVF, where L is the cellular space defined by a set of cells. V is the neighborhood set. It contains all the cells whose states have an impact on the evolution of the chosen cell. The transition function F calculates the state of each cell, say at time t plus 1, using its neighborhood at time t. F is defined to Sn, from Sn to S. Our model is based on coupling CM CA model and MEDALUS assessment. It consists to predict the evolution of desertification phenomenon using a cellular automata model whose transition function F is based on MEDALUS assessment, where L is two-dimensional network of cells. S is the state of cell in the interval 1 to 2, because DSC is in this interval. The state of a cell denoted SC is represented by its DSC. Neighborhood is Moore's order 1. The neighborhood is the 8 cell around, the central cell, the 8 cell around the central cell. The state of the neighborhood is the geometric mean of the state of its neighbors. Transition function F take into account three important properties of land evolution: irreversibility. Desertification or very degraded state is almost irreversible in degradation situation. Stress condition, bad climate condition and human pressure lead to a stress condition in exposed land. Normal evolution, interaction with neighborhood, land can evolve. Transition function F mapped the state SC of the cell C at time t to its state at SC plus at time t plus 1 according its neighborhood. Defined by this notion, where SC plus is identity of SC if we are in the condition of irreversibility. SC plus is SNC if you are in the particular case of stress. Mean of I5 is the range of very degraded state, desertified state. Mean of I5. In the normal condition, the geometric mean of SC and SNC in the normal case. Now, the stress case is defined by the two cases. The first, the state of cell C and its neighborhood to reach the upper part of the range of degraded state, such as the second case, the state of cell C reach the upper part of the range of high state and neighborhood reach the upper part of the range of very degraded states, such as this question. With this transition function, a cell must be in the process of degradation if its state SC is lower than SC plus. The state is in the phase of regeneration if SC is greater than SC plus, and the state is in the condition of stability if conservation if SC and SNC is in the same range. Our model must verify this three condition. Picture one presents the initial configuration and area given by MEDALUS assessment. In these pictures, the grid is a square with side equal to 40. The cell in orange are very degraded.
Please, you have 1 more minute. 1 more. You have 1 more minute.
1 month, yes. Cell in dark green have low degraded. So they are the low degraded and moderate, high, and degraded. In this grid simulation, we notice that the process of degradation, regeneration, and stability are observed. Very degraded state in orange, which state are irreversible, participate in the degradation process. The cell with good state improve their neighborhood. The stress cell are desertified from T to equal to N. and contribute to the degradation of the neighboring areas. The very degraded cell curve is growing and degraded cell curve is decreasing, growing. This is explained by the fact that the major part of degraded cells became very degraded in degradation situation. This model is based on continuous cellular automata whose state, set, and transition function were extracted from the MEDALUS method. This model allowed to predict the evolution of an area with moderate slope and annual time step. The usage of more neighborhood of radius 1 allowed to consider the influence of all the surrounding neighboring cells. This work is validated by geographers specializing in the study of desertification. It has been improved by adding additional parameters to serve as basis for the development of software for monitoring and degradation. The work of this software constitutes our next publication. Thank you. Thank you.
Thanks a lot, Alassane. Thanks a lot for the presentation.